Math 2, Unit 8, Worksheet 2. We're just going to go over numbers 2 through 7. This is Mr. Trutna from Clovis High School. And here is our worksheet. Okay, so once again, we're just going to do numbers 2 through 7. So in numbers 2, 3, and 4, we are going to write the expression in radical form. So we're given k to the exponent of 3 over 2, or 3 halves. So to write this in radical form, that means we're going to put the radical symbol. The base of the exponent will become the radicand. The denominator of the exponent, which in this case is 2, will become the index. So I'm going to put a 2 right there. And then the numerator for the exponent, which is in this case a 3, will become the power that the radicand comes in. So in radical form, k to the 3 over 2 power is going to become the radical with an index of 2, k of 3. Now, that is an okay answer to write, but once again, if the index is 2, it is unnecessary to write it. So if the index is 2, we don't write it, it's just implied that it's 2. So this would be the answer that we're looking for in number 2 in radical form. Okay, following that same pattern, number 3, 3 to the 2/5 power. To put it in radical form, I would put the radical symbol. The radicand would become the base of whatever the exponent was, which in this case is 3. The index is the denominator of the exponent, which in this case is 5. And then the radicand is going to be raised to the power of whatever the numerator is, which is 2. Okay, so 3 to the 2/5 power in radical form would be the radical with an index of 5 of 3 to the 2nd power. Now we're not simplifying this, so we're just going to leave our answer like that. All right, number 4, x to the 1/3 power, written as a radical. My radicand would be the base, which is x. My index would be the denominator, which is 3. And then this x, the radicand, would have an exponent of the numerator, which is 1. I do not have to write a 1 there, so really what we would be looking for in number 4 would just be the 3rd root of x. That's how we would say that in words, or some people might call this, or will call this, the cube root of x. Okay, number 5, what we are doing is we are writing the expression in exponential form. So you're given the problem in radical form, and then you're changing it so that it is in exponential form. Okay, so the first thing you want to do is, especially in a problem like number 5, where you have a coefficient and you have a variable, you want to see if they have the same exponents on each part here. So this 2 actually technically has an exponent of 1. This x also has an exponent of 1. Now it's very important if those two exponents are the same or they are different. So if they're the same, when I write my problem in exponential form, I could take the radicand, which is 2x, and I could lump them together into one part, and by showing parentheses. Okay, the parentheses are telling me that both the 2 and the x have the same exponent in radical form, and then I write the exponent. I take whatever the exponent the radicands are, which is 1, and I put that as my numerator, and then my denominator is the index of the radicand, or the radical sign, excuse me. Since there is no index showing, that's implied that it is a 2. Okay, so that right there is going to be a 2. So number 5 would be 2x in parentheses to the 1/2 power. Okay, now just a side point here, you have to put the 2x in parentheses. If you did not, oh, the lights just went out in the classroom. All right, the lights are back on. I actually had to do a lap around the classroom to get the lights to go back on. Now, going back to this, if you wrote this problem like this, and you did not put the 2x in parentheses, this would be wrong for this example, because this is showing us that only the x is to the 1/2 power. Okay, so that would be no, don't do that. All right. Number 6, When I convert this, or I write it in exponential form, I only have one radicand to worry about, and that's f. So this would be, when I put in exponential form, that's my base, and then my exponent would be 2/3. Okay? The numerator is whatever the radicand's exponent is, which is 2. The denominator is whatever the index is, which is 3. Okay? Now we get to number 7. We have radical with an index of 4 of 5x to the third power. Now, once again, when you have a coefficient and a variable, you want to see if they have the same exponents. Well, that x has an exponent of 3, but that 5 has an exponent of 1. Okay, so because they have different exponents, you have to think of this problem almost like this, where as if you had a index of 4 of 5 to the 1 power, and then you were multiplying it by an index of 4 of x to the third power. You almost have to think of it as two different problems. Converting this first part into exponential form would become 5 to the 1/4 power. Converting the second part into exponential form, it would become x to the 3/4 power. Okay, so that would be number 7 in exponential form.